Okay, well, welcome to this lecture, and you saw that little teaser at the beginning about what's going on here. We're going to control the output of LuckFox to its GPIO pins via VLM LLM combination here. And so kind of a pretty fun project. Actually quite simple with the help of Gemini in the coding, but just the thinking about it isn't too bad either. So let's look at what we're trying to do here. So we've got a goal. The goal is to have the LuckFox have these eyes, the eyes of the camera, and we're going to kind of curate this particular case so that it's looking for, when we write the word blue LED, red LED, and so on, and when it reads that word, it's going to turn on whatever LEDs it reads. So maybe it'll read red LED and blue LED, and it'll turn red and blue on, and then it'll keep the yellow and the green off. So kind of a contrived situation, but you could imagine a more general case where if it just sees red, it will turn on red, or if it sees a person, it will turn on an LED or do something. So I think it's pretty easy to see how this would be able to capitalize on the characters, just sort of this great phenomena that comes about in large language models and visual language models, where we're able to describe and interpret to some degree an image. Now, we're going to be running this on a local system that involves a client-server setup. So the client is going to be the LuckFox. It's going to have the camera. It's going to send its image, what it sees, to server. This will be running on just my main machine. It does have a NVIDIA GPU, not a I think it's a 3060. So it's not a super poppin' machine, but can easily handle these smaller models. And it would be interesting to try this if you've got a really powerful machine to incorporate some higher level thinking with the larger model LLMs. So we're going to have this back and forth. The image is going to come here. Then the server will send that image to MoonDream, and then MoonDream will create a caption. So one of the things MoonDream is good at, a very lightweight model, but it creates a caption for whatever it sees. Then that caption is going to be sent to Phi to do some parsing. So we're looking for the words red LED, yellow LED, green LED, blue LED. And if those words appear, and we're utilizing the fact that Moonbeam tends to always, if it's got some written out words, it does, it captures that and always writes that verbatim, or it seems to. I don't know if it always does, but that's been my experience, been pretty robust in that regard. So it will see what Moonbeam will have put that in the caption. Like, I see a whiteboard with markers and all this, so it'll give a lot of detail, but it'll also say with red LED written on the board. And so then Phi will parse that, compare it against the list that we're looking for. So we will hard code in this list. Again, we could try to be a little looser with that, but we'll hard code that in. That will get sent back. I probably shouldn't really say caption here, but the stripped down caption will be sent back to the client. And if it reads red LED, then it's just an if else, it'll send all that it sees, like red LED, blue LED, as a list. Whatever appears in there, if that appears in there, then there's the remaining logic of the program will just simply turn on the GPIO pin appropriate with that color. Okay, so kind of what I said here. Let's say it reads blue LED. So I write blue LED on the board, and the image is taken by the LuckFox. The image is described by Moonbeam. It's parsed, put in this array could have more than just blue LED written, as we saw in the intro, and then that's sent back. So that's the idea. References here, if you're just starting with your LuckFox, and this is the first video you came to, you're coming to part of a long series, and we've done a lot kind of building up to this. So you would if you just want to get into this, then I would suggest looking at the LuckFox tutorial and Fusion Automate YouTube channel. It shows you how to install Ubuntu on the LuckFox, which is what we're using here. And then you can get up and go. And then you will also need to look at our Lab 13, because there's a fair bit of work you need to do to get a webcam going. And not all webcams work. It does seem like the more modern webcams do. My older webcam, I never could get that to work. The other thing that I just noticed when I was setting this up is I wanted this camera that I'm talking to you in to be doing the reading, but I have to have a extender cable, and with that extender cable, it doesn't work. And so you might be able to see popping up in the bottom of the screen here a separate camera, and I can just barely reach over to my LuckFox setup with this camera. If I put an extender on this, doesn't work. So that's kind of a well-known thing. If you have to propagate your signal, there might be enough loss or something that it causes a problem. Interestingly, this camera does work in its normal fashion on the computer and with OBS here, but it does not work with the LuckFox setup. Okay, so hopefully you have a camera that will work, and this lab 13 takes you through that. So with that, let's jump into the setup. So there'll be a couple of things we'll see here: the board itself, or the LuckFox itself, and then the programs, and then we'll look at again a little bit more extended version of what we saw in the opening introduction here. Okay, let's take a look at the setup here. So for those of you who've been following this series, we've put together a rack of a rack here of 4 LuckFoxes, but you don't need that. You just need a single LuckFox. I'm running everything off of the top LuckFox here, which I happen to be calling LuckFox 206 based on the IP address that I've given to it. This is just some rack status of these, and so again you might see the 206 down here at the bottom. So that's the LuckFox we're running off of. You can see here I've got, in a very flaky way, my webcam set up, and so very easy to get that not connected, and you'll get an error, then it won't send the image. Otherwise, this is connected to a USB to a USB-C converter there, because the LuckFox just carries the USB-C converter. You will need to have this set up as a host. I'm not going to go through that in this video, so go look at Lab 13, I think it is, and in that one we set up the camera, and that I just did. That's exactly what you use here. Okay, if we slide over just a little bit, we can see these are going to, the black is going to a ground pin, and then these 3 pins are going to, if we look at our handy sheet here, we want to find some available GPIOs. You can choose whatever you would like. I'm choosing physical pins 4 through 7, but remember, we need to communicate to the LuckFox with the calculated pin value, so that's 55 or 52 through 55. So we've got these 4 all in order, and they are going down to the, maybe a little bit harder to see here, blue LED over here, green, red, and yellow LEDs for this setup. There are some protection resistors here. I use 470. You could use a 330 ohm resistor. And so very, very simple electronic setup, very simple interface to the LuckFox, because it's simply GPIO. So the code is just, the logic of the code is just when it sees the word green LED in the text, it just sends a high to the green pin. If it doesn't see it, it sends a low. So pretty simple logic, and yet it's kind of cool how it pulls in some of the new modern VLMs and LLMs. Okay, so let's get the files we need and set up the server side on your main machine, and then the LuckFox itself. So if we just Google my name and then the darrenolmus.com, and then we'll go to teaching LuckFox microcontrollers, and way down at the bottom here we have some zip files. So just download those, put those in a directory that you would like to work out of. I've already done that, so let me just go to that directory here. So here's the MoonDream zip. You won't need that anymore after you extract it. This is the PDF. I'm going to show this here to you. Whoops. And we're basically going to follow this. I don't think I'll have this up going step by step. Instead, I have a kind of a cheat sheet here, so you don't have to watch me type everything in. I'll just copy that in. Okay, but you can find this. And I did try to have a Windows version, although I was not able to test it. And so I'm just relying on Gemini's understanding of how it would run on Windows machine. So as my server, I'm using this Linux machine. Okay, so we've got then the main file. This needs to be in this directory, whatever directory you're going to be serving out of. The requirements text, this is just, I'll open this up here. This is just the libraries that we need. And we'll see if this works right off the bat. There are a couple of changes that we'll go through as we go through the setup. And then we will have the last file here. This is actually not needed, but what we'll do is we'll open this up and copy it over to the LuckFox. So this is the file that runs on the LuckFox. So we really just need main and requirements. We really wouldn't even need requirements because we could just hand type those in, but we'll do it in one shot here with the requirements. Okay, so now what we'll do is we'll go to that very same directory here in the terminal. So I'll just ls this, and this is where we were. So here's the main file and so on. So now I'll pull up my cheat sheet. Okay, got my cheat sheet up here. We'll create a virtual environment. Then we'll activate that environment. And now we will install our requirements. Copy. Maybe I'll pause and come back. Okay, that's done. Now, we need to actually upgrade the transformers package. So let's copy and paste that in and do that. Okay, now we will launch the server. And it is running now, so this should serve. Okay, so I'm over here. We're on the LuckFox, so I'm going to minimize this now. We don't need this anymore, and let's get these side by side. And we'll look here. There's nothing in this LuckFox directory yet. So what we're going to do is go sudo nano DingaVision, or whatever you called your file. What did we call this thing? DingaVision client. PY. And now I'm going to copy all this. So this is just the file that was in the zip folder. Paste it here, and then Control X and Y, and we're out. Now, if everything is working, we should just be able to run this. Right now I have just GNL project written on the whiteboard. So it should read something to that effect. So let's go ahead and go sudo Python. We're to jump in here. I should have mentioned this. If you haven't been using your LuckFox for GPIO, then you may have gotten an error, or you may get an error that you that it won't work because we don't have the Python periphery libraries installed here. So many of you probably have this already installed, but if you just simply go to pip install Python-periphery. So I always mess up because it'll say module, periphery module not found or something like that, and the full name of the module is Python-periphery. Now mine's already installed, so this won't do much, but it's already installed. So you should install that if you haven't already done so. It's initializing the camera, save the web camera image. So that's this right here. Then it sent that over. If we look over here, it sent that file over here. So file received a file, and then it created a caption. And then the LuckFox got that caption back, and then it saw that nothing on the board was written as LED. So we get no turning on of the LED. I'm going to go now change and write green LED or blue LED on the board. I've written blue LED on the board, and now it's waiting for the cycle. Should be capturing an image. And there it is. It says blue LED over here. This gets completely stripped out. It turns on the LED. All right, so that's the working aspect of it. Let's look at the file to kind of see a little bit more about the file. So I'm going to close this, and we'll go sudo. Okay, let's look at the client side program here. So requests is the package needed to talk over the LAN. Periphery is the package needed to actually turn on the GPIOs. Now, what you're going to need to do is make sure that you know your IP address. And so in my case, it's 192.168.50.4. So you'll need to figure that out. And then we're going to be talking on port 8000. And then this just concatenates all of this. And we do need to leave this image analyze as is. Now, another thing that could be different is your camera device. It might be not video 0. So you'll want to make sure that this could be video 1, video 2. It's probably video 0 though. Then you'll want to use the calculated pin numbers, not the physical pin numbers on the LuckFox. So consult the handy LuckFox pinout diagram. And so I'm happening to be using for 52 through 55. Then I think the rest of this is just calling or handling the transfer of the files. So I don't think I'll go into this too much. If you want to scrutinize it, you sure can. Again, I've got essentially all the help from Gemini Pro here. So I didn't add anything of my own accord down through here. Okay, so let's get out of here. And now let's take a look at the main program. And we'll get a look at this. Again, Gemini Pro wrote most of this for me, but all this stuff here is designed to call the Moonbeam and the Phi programs, LLMs. Now, when you first run this, it might take a while because it's going to draw those down, and that can take a little while. But then every time after that, it shouldn't take too long. Now, here's one critical command here. This is utilizing your GPU if you have it. Otherwise, it will default to a CPU. So you still can run this. You're going to find it's frustratingly slow. So you really do need a GPU with the CODA capability to actually run this in kind of an effective manner. But you could try it with your CPU. It might work if you put a longer delay in between and you're willing to wait for a while to have the change in the LED. It might still work. There's not much to it, really. It's just, again, largely Gemini wrote this for me, so I just kind of let it go. The basic idea is that it's looking for keywords, and so we actually really don't need the all off here, but I added that. But so it is a little bit scripted here. It is looking for red LED, yellow LED, green LED. So if I had just written green or something like that, it wouldn't have inferred that. We likely could, although these models are very lightweight, we likely could have it infer that. That could be something that you could try if you want to go further with this project. All right, so I know it's a very quick discussion of the code, mainly because it's not really my code, it's Gemini's code. But between Gemini and I, we were able to frame the project. And so I just wanted to talk to you a little bit about the things that I was thinking about for that program. All right. Okay, now that we've gone through the hardware setup and the software setup, let's look at this in action again. So this will be like what we saw at the very intro, the teaser at the intro of the video. What we will do is we'll see this, we'll cycle through every 30 seconds. And so I'll cut down the time so we're not just staring at the whiteboard for 30 seconds. So this will be going faster than it's going in real time.